Group 4A here with a quick presentation on how to solve problem number 7 from homework 1. First thing we're going to do is we are going to take a look at our problem statement and get any kind of useful data that we're able to extract out of that. Doing so, we see that we find the cross-sectional area in all of our members is equal to 1.25 inches squared, and that the maximum stress allowable on each of the members is 20,000 pounds per square inch. Next thing, let's go over a couple of equations we're going to need. We're going to need Pythagorean. We're going to need our stress equation. We're going to need, for a couple of substitutions, sine theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And we'll need 2 of our equilibrium equations to help us solve these. Next thing that we really need to do here is analyze these 2 identical triangles. So you may be looking at these and notice right away that these are 3, 4, 5 triangles. If not, that's okay. Let's go over that. So we're going to use Pythagorean. We get that 4 squared plus 3 squared is going to be equal to our hypotenuse, giving us a hypotenuse of 5. Next, if we take theta to be this angle, we can make a couple of useful substitutions here. So we see that cosine is going to be equal to 3 over 5, and sine is going to be equal to 4 over 5. Next thing we're going to do is use our method of joints to analyze this truss, and we see that if we analyze joint A, B, and C, we'll be able to determine the force in all of our members. So first thing, we draw our free body diagram for A. Looks as such. We write our equations of equilibrium. One thing to notice here is that we have 0.5p coming in from this direction, and this is going to be cosine of FAC coming in from this direction. However, we already know that anywhere we see cosine, we can plug in 3/5. So this becomes our equation. Solving for this, for our force in terms of P, we get that FAC is going to be equal to 0.833p. Same thing, sum of the forces in the y equals 0. We find that FAB is going to be equal to 0.667p. Continuing on, we're going to analyze joint B and C. Doing so, we get free body diagrams that look like this. Next thing, we write our equations, and we find the force in all of our members. Now, these are all in terms of P. So next thing we need to do is find out which one of these has the highest multiple of P, because that's going to tell us which member is responsible for supporting the maximum amount of the load P when applied. So we see that this force the force in member CE is going to be a highest multiple of P at 2.667 P. The next thing we're going to do is we're going to plug these values into our stress equation. That's going to look like, it's going to look like this. We get the maximum allowable stress is going to be equal to the maximum force over our cross-sectional area. Plugging in our values, we see that we have an equation that looks like such. Solving this for P, we find that the maximum magnitude of P is going to be equal to 9.375 thousand pounds. That will be our final answer. So thank you for watching. I hope you found this useful.